Okay, welcome back everyone. So, in this is a problem. Okay. I would like to find an integer x such that the sum of the digits of this thing um decreases. Yeah. Uh uh-huh. Okay. Um what? I mean, okay, how big is 2 to the 50? That's my first question. How big is 2 to the 50? 2 to the 50 is like one is about 1,000 to the 5, which is about okay, 1,000 to the 5 is exactly equal to 10 to the 15. That much I can do. Okay. um, so there's a lot of doublings. I'm not sure they depend on. So I have a lot of space, right? So I need to do 50 things, and I have like 10,000 digits of space, and inside each block is there a concept of block I want to use? All right, let me think this through. Um, this is a finite case check. Um, for some very generous definitions of finite, I agree. It should be x less than 10 to the 10 to the 4. Oh, god damn it. Okay. Uh, yeah, that's definitely going to help the brute force solution. Okay. Like I have this idea where you can try to make this integer x into like, you know, a bunch of block-like things. So you have like some number, a bunch of zeros, another number, like another more than 15 zeros, and so on. And if you do that, then the sum of the digits will be equal to like the sum of like the things in each individual block. And then what you might try to do is you can choose the starting number in each block, and you can choose the number of times you repeat each block. Hmm. I actually I think I can do the problem already if you don't have an upper bound. I might eat those words momentarily. No, sorry, that's false. Okay, no, that thing I have doesn't work. Okay, I ate those words very quickly. Uh, but it's kind of like you have these parameters, which is that you can. Let me be concrete, okay? Like, suppose I pick my number to be 1, like a bunch of zeros, and then like 3, a bunch of zeros, 5. Let me give this as an example. Well, actually, even not just 1, 3, 5, just like, I don't know if there's good notation for this. Well, we'll just say 0, 0, 1, repeated a bunch of times, and we're just going to assume there's a lot of zeros for now, because this is just an example prototype, so I'm not going to even bother optimizing yet. Then you can imagine that, like, sum of x is like a plus 3b plus 5c, and then s of 2x is equal to 2a plus 6b plus 1c, and then s of 4x is equal to 12, which goes back to down to 3, and then 5, okay, 1, 2, so something like this, right? And when you look at this example, if I was only trying to get 3 numbers to work, you'll notice that the maximum is in different places. Like, the largest coefficient is in a different place each time. Is that good enough? I'm not sure if that's good enough. Yeah, okay, there's some sort of like non-negative integer programming thing that you need this to, okay, so it's not super obvious to me that this is going to... But I think there should be an idea, because I feel like the digit length given is so long that I do like the idea of having some blocks like this, but I don't know how to pick the blocks right now. I want to pick the blocks such that, yeah, I don't know. It's fundamentally... Wait. I don't get why... Wait, is it... Is 2a plus 6b plus c not just obviously? Like, it's literally like, you write 2x and it's like 2, 6, 10. Right? Like, I think these equations are fine. It's just, I don't... Maybe there's a way to... I mean, I picked 1, 3, 5, like, just at random. Just like, I was like, here, have these random numbers that I made up. What's a number that implodes into tiny? Yeah. What I want is small, 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 big, small, small, small. So can I get a cycle of some sort? Is that... Yeah, if I use powers of 5, so the nice thing about powers of 5 is that, you know, after a certain time they decay, you get 1. And that is something that behaves, so if you have a really long power of 5, is it true that the sum of the digits of that power of 5 is big? Well, I only need 50 things anyways. I feel like that shouldn't be... Yeah, actually, powers of 5 feels like it should just kind of work. Okay, so building off this idea, what we're going to do is... in fact, I don't even need the multiplicities if I'm doing it that way. What I'm going to do is here's like... let me make sure I get this right. No, wait, hang on. 5 is... No, 5 would not be big enough. Maybe I want to repeat it a bunch of times. Sorry, I lied about the large powers of 5. So powers of 5 doesn't work quite as easily as I thought that I made it sound in my head. Yeah, I agree that if you had a thing such that when you doubled it, the digit sum suddenly became a lot smaller, that would do the trick. Yeah. I don't know. Somehow it feels like powers of 5 grow pretty rapidly compared to powers of 2. So it seems like the implosion should like somehow... Like the sum of digits of 5 to the I is a lot bigger than the sum of digits of like 2 to the I for like quote unquote random I. Actually, maybe that's just true, period. Is that true? Okay, actually... question. Is sum of digits of 5 to the I larger than the sum of digits of 2 to the I for all I? Is this a true statement? And if not, is it true for all I less than or equal to 50? Because if so, we might... That would be pretty good. Okay, I agree the first one feels like it might be open. Is the second... Isn't what we actually want 5 to the I plus 1? That's just false. Yeah, that's not true. 3125 is a counterexample. But if they're like, if it's like big enough on average... I don't know. Fuck. Actually, what's the Nightbot command that explains how to... I never remember the... Ah, it's yeah, it's X request. Okay. Yeah, I don't know. It somehow feels like I kind of see what incomplete is saying, where it's like if you look at the sum of digits of 5 to the n, like it's not literally monotonic, but it feels like pretty close. It feels like on average. Like here's the claim. I claim that if I literally just take the powers of 5 and stick them together, if I put enough of them, it seems like it, like, quote unquote, should work. Because the sum of the digits definitely, like, is... skewed. So that you have this... Yeah, okay. So I don't actually know what the answer to either of the questions in red are, but I feel like this is on the way. Random question. In order for this to work, the inequality that I need to be true, if I ignore the bound, I think this will fit in the bound because the numbers don't grow that quickly. So let's say I go up until, let's say 5 to the n for some capital N. So in order for this to be true, what I need is the sum of the digits. So at each step, I take the largest power of 5 and replace it with the smaller power of 2. And this feels like if I pick a big enough n, if I pick a really big value of n, then, you know, if this is true, we're good. We're Gucci. And okay, so I guess the first question I should ask is how big can I get n and have this still fit? So I get 10,000 digits of space, and if I have 10,000 digits of space, I can take like a really big, like even n equals 1,000 I think is fine. Because like the number of digits in 5 to the... Okay, I need to make sure I don't. So it's like you have n powers of 5, and then n times the amount of space it takes to write that down, which is like n log 5. Okay, I think n equals 1,000 is definitely not fine. Like 2n log 5. But like n equals like 80 is probably okay, right? I need this less than 10 to the 4. Like how much zero padding do I need? Okay, you can like kind of optimize the constants a little bit. I don't know how useful that is, but it seems like you can get like n equals like 80-ish, and it's kind of okay. That's pretty bad. I need like 83 664. I see. Dude, yeah. So the 10 to the 4 is actually... Like, okay, I guess the way you optimize this is I've been writing this as blocks, but what I really should say is I have like a number of zeros that is corresponds to the yeah, I was hoping I wouldn't have to optimize the constants as much. But it looks something like this, right? Where I have a bunch of zeros for everything to make sure there's no interference, and then yeah, so it's a fixed number of zeros plus however long it takes to write. And the point is, if I can get like n to be like 100-ish, and I think n equals 100 fits. But if that's true, then we're pretty happy with this inequality, right? Because we're like, this is probably just true just for like, you know, quality, like, okay, anyways, yeah, I'm assuming this is why this is on a programming contest, because you know, this thing is true, but I don't think you can, like, this inequality must be true for, like, n equals 100. I like, feel very sure that this inequality is just true for, n equals 100, because 5 to the n, it grows way faster than 2 to the n. But yeah, there's no way to verify it on a math Olympiad. However, for a coding contest, this is, you know, the numbers are small enough you can verify it. Okay, so yeah, I probably do have to actually look at the AtCoder now, because presumably the way that we check that we got a valid x is just submit it. Okay, how do I decrease in digit sums? I see. The input is literally 50. That's pretty funny. All right. Okay, let's start writing some code. Prayers. So, what I want to say is, first of all, for let n equals 100, and we'll define s as the sum of digits. I'm not going to return some int digit for d in string. All right, this is the sum of digits function. So assert s of 1337 equals 14. We'll also assert n greater than 0. Okay, so for I in range 151, assert s of 5 to the n minus I is at least s of 2 to the I minus 1. This is what we need to be true in order for this construction to work. Okay, it's true. Great. Now we can... So, yeah, okay. Now let's write the code. AtCoder. Okay, so how many zeros do I need? So I need to have the property that when I multiply the largest number 2 to the 50, right? 2 to the 50, that's not even that big. That's like... Wait, that's a lot smaller than I was... Wait, hang on. No. 2 to the 50 only? Okay. So I think like 30 zeros should be enough, right? Alright, okay, no, just 50, okay. Like I think 16 zeros should be enough. For I in range 1, and we, x plus equals string 5 to the I. And print x. Well, okay, let me read the first 100 digits to make sure that's doing what I think it is. Yeah. Let me pad it with 20 things and see if it fits. 5,000 digits. That's much less. Okay, anyways, we're just gonna submit this. I hope this works. Submit. Wait, I probably should have read the full problem statement and made sure that I'm printing it in a... Okay. We're awaiting judgment. Accepted! Yeah! Okay. Nice. Okay. All right. So yeah, that this is very interesting actually, because it's like you from a Math Olympiad side, there's no way you can easily prove this construction works. But from the like code side, it's just like, come on, it has to work. Like, there's no way it doesn't work. The editorial, what? 651 works? Oh no, 651 digits. Okay, never mind. Yeah, it's, oh, this is interesting. Yeah. Nice. Alright, yeah, that was interesting. I like the idea behind the problem. It's like, it doesn't fit in a Math Olympiad exam format, but it's still a good problem, I think. Yeah. Huh, okay. I'm trying to think, like, is there a way I can adapt a problem like this for a math contest, but I'm not sure. That's a shame. I wanted to use something like this on a math contest, but I don't see how. Oh, you average from 50 to 65. Okay. What is this? Okay. Anyways, let me cut the video here just so I don't ramble too much. But for those of you that are on YouTube, thanks for tuning in, and we will see you next time.